To start off, we need to enable the plugin. So if we go to our plugins and type in PCG, you want to enable Procedural Content Generation Framework. Restart. After that's done, we're going to be making an actor for our spline, which we'll just call BP Spline. And we want to make a PCG Graph. And we can choose the default empty graph. So we'll open up our spline, and we're going to add the PCG component. And we're also going to be adding a spline. For the PCG graph, we're going to add the new graph that we just made. And then we can open our graph. So if you've seen my previous video on how to make the grind rail with our spline blueprint, we're effectively following the same method of adding a spline mesh component, setting the forward axis, giving it a static mesh, calculating the tangents so then the mesh curves along the spline point, and setting collision to be enabled. But we're going to be doing all of that in the graph, and it's going to be more performant than using the construction script of our spline blueprint. So to start off, we need to get the spline data. And for the actor filter, we want to get all world actors since this is going to be placed in the world. We'll get it by class, and we'll choose our BP spline as the specific spline actor that we'll be using. Once that's done, we'll get a spline sampler. This will allow us to start constructing the spline itself. And we have all of these options available to us. We only need to worry about only a few. First, we're going to go up to the mode for our spline and change it to distance from subdivisions. And we want to check this to be unbound. Now, when we set a PCG graph, having it bounded means that it's going to be within the confines of a collision box somewhere, either a PCG volume that's dragged onto the map, or you can plug it into a box collision or any other collision that's specifically within the actor. We don't specifically care about that. We're going to be using it without any bounds. This way it could be placed literally anywhere within your level. Then we're going to drag out from the out pin, and we're going to get the bounds modifier. This will just give us a default scale. Then we want to create the spline. And we can leave that as the default. And finally, we're going to spawn our spline mesh. And in our spline mesh parameters, this is where we set the forward axis. We only set the spline's up direction, any offsets. We're going to open up the spline mesh descriptor. And for our component class of spline mesh component, we're going to be adding the pipe mesh. Everything else for the mesh is handled here as normal. We're going to set the collision to block all. Then we can just minimize this menu, go back to the parameters. You can open up the mesh specifically to view this information, but I know off the top of my head, the pipe mesh forward vector is going to be on the y-axis for it to go lengthwise. And then we'll save that. So if we go back into our map and we drag in our spline, you'll see that it spawns the mesh right on top of the spline line. And when we add more length and more spline points, it automatically curves everything to the spline. So next, we want to make sure that we can get this generated in the game. So we're going to be spawning this spline blueprint, and so long as we have it active, we're going to be adding spline points onto the map. Then once that point is placed, we're going to update the PCG graph so then it can populate the spline with the spline meshes. So to do that, We'll get a keyboard event. And we'll bind that to right mouse click. We're going to set a timer. Make a custom event. We'll call it check spawn point. Have that be looping at 0.01. And looping doesn't have to be 0.01, but I'm just going to set that. Then when we release this, we're going to stop the timer. So we'll clear and invalidate the timer by handle. And we'll get a line trace. We'll start at our actor's location. And we're going to be using the follow camera's forward vector. That way it'll just spawn where we're looking rather than where we're facing for easier control. We'll multiply this by a distance ahead of us, say 400. And we'll add that to the location of our actor, and then add about 200 to the Z axis because our follow camera is going to go directly through the mesh's head, so we won't be able to see it unless we add something to it. Then we'll get a branch for when we hit, and we'll break the out hit. And we'll get the impact point, promote it to a variable. We want to spawn this a little bit above the floor of the map, so we'll add 100 to the Z value of the impact point and set that to be where it spawns. And we'll make a Boolean. And we'll call it can place. So when that's true, if we left click, then we can add a point. Otherwise, if it's not valid, then we'll just ignore the command. So we'll just check that to be true. And then off of our clear and invalidate timer, we'll set that to be false because we're no longer running it. And for the next part, we'll get our line trace by channel, copy it over for false. The start and end point are going to be the trace end. However, for the Z value on the end, we're going to break and split the end, so then we're only using the X and Y. And then the Z value is going to be -500, so it goes directly down. So we have sort of a crane, or if we're looking directly at the ground, that's where our spline point is going to be set. So we'll copy our can place and connect that directly to the return value because we're either going to set can place to be true if we hit something, or it's going to be false if we don't. Then we'll get a branch so that if this is true, break the out hit, and again, we'll take the impact point and set that to be 100 units above where the trace intersects. So now we'll copy this and we'll change it to the left mouse button. Get a branch, so then we're only placing this if we can place it. So we'll spawn an actor from class. The class is going to be BP Spline. Then promote it to a variable. Just going to call it Spline BP. And we're going to get a validated get off of true. So if it's not valid, we're going to be spawning this. We can split the spawn transform, and we're going to just add the impact point. Instead of leaving this at 0, we'll just get the actor's rotation. And set that to be the same. And if this is valid, we'll get the spline blueprint. We'll get our spline. will add a spline point. And that position is going to be our impact point, and we want to change the coordinate space to world. Then off of our spline blueprint, we want to get the PCG component. So get PCG, and specifically we want to get notify properties change from blueprint. This is what allows you to specifically update the PCG graph manually, as it's not updated in real time. And then we'll go and we'll turn off our traces. And then we'll go to our spline blueprint, and either to the default scene root, or if you drag spline into the scene root, it's going to give you an error unless you set the mobility to static. So when we click, we spawn our spline, and as we are looking and keep clicking, we can add more of a spline to it. So renaming the spline blueprint to exactly what we had with the grind rail tutorial. Whenever we generate a spline, we're effectively making our own grind rail, and we can add spline points as we go, though I'm manually clicking rather than having anything more robust. And as I go, I can keep adding more and more spline points as I click rapidly, although you'll start to notice that there is a little bit of shuttering, not with the system itself, but with it populating the spline meshes. This is because even though we can generate it, it may take a small bit of time to populate the meshes into the spline line. And the longer that the spline gets, the longer it's going to take to finish mapping out those meshes. So the PCG graph is able to very easily do exactly what you're seeing on the screen. How does it compare performance-wise? Well, number one, it's very easy to do the PCG graph to make a procedurally generated spline, because it doesn't require anywhere near as much math as what you're seeing here. Effectively, we're manually calculating the tangents of every spline point between each section, and we're also calculating the section length of each pipe mesh and placing it on the spline between each spline point. So I switched over the blueprint, and it performs pretty much exactly the same way. It's not as smooth, so we can see adding like these really short spline sections, so we could see a little bit more deformity happening in between each mesh. And I can already hear my graphics card starting to rev up, where it wasn't doing that before. So this has already been running longer than the PCG graph, and other than just using a little bit more power on my computer, it's not slowing down. It's not taking a lot of time to catch up to where I'm placing all these spline points, and there are so many of them that I can just keep going. Performance-wise, probably not the best, but with a little tooling and going back and removing old spline points, either some algorithm or heuristically, can drastically improve the performance of both. However, it looks much better using the PCG graph. This was the 5th video I've done on splines. 5 more, and YouTube mails me a free Sunday, so there's probably going to be more in the future. But for now, I want to say thank you to the members who have been so kind to me in their support: Winterberry Shark, K Panic, Shay Alexander, and Wolfpaws, and to everyone else who supported me as well. If you like what I do, you can support me on Ko-fi. The link is in the description. There's projects, both free and for members. There's tutoring, animations that I've done, and a bit more. But that's all I've got for you for now, so thank you all for watching, and I hope you've been inspired.